Hey everybody, this is Matt, and I have another addition to make to this electric universe thing. And this is going to be a response to the last video that I did that tried to explain exactly why the face of the moon was as it is, facing us and nowhere else. And so I'm going to kind of make an addendum here because I tried to explain things to the best of my knowledge, and with this electric universe thing, I'm constantly in a learning process. There's a lot more people out there that have a lot more experience trying to explain the concepts and have ideas that are different than the mainstream science that is being presented to us at the school level and on the science channels and all that. Bill Nye be damned, you know what I mean? But in any case, the first, I want to explain exactly why I'm kind of adopting this new idea. And it's an idea, and we haven't actually proven either idea. So this is the new idea that I've kind of learned by listening to this guy called Wal Thornhill. And Wal Thornhill is kind of one of the leading experts and longtime proponents of the electric universe theory. And he has a lot of different predictions, I guess, that have come true in relation to the collisions of like the Shoemaker-Levy comet on Jupiter, and also the recent landing of a probe on a comet. He predicted some things like there would be an explosion, and the explosions that were experienced or were observed by scientists that happened in the events of the Shoemaker-Levy comet collision with Jupiter, and also the running of the probe into the comet. I forget which one. He predicted that, and all the other scientists were surprised. So, kind of lends a little bit of credence to his expertise in this area. Essentially, what he's stating is that the electric charge in those objects basically created an electric arc, and that's basically what caused those explosions in those two particular events. And so he made a video the other day, and I'm going to link it in the description below. And he was talking about the Juno mission to Jupiter, which is going to end with, or begin with, the peering into the surface of Jupiter, and in particularly the spot that rotates around Jupiter. And he made some fairly interesting predictions about that spot, and I'm going to let him explain that a little bit more, just so, and I'll leave once again the video in the description. But essentially what he's saying is that there is a planet or a small moon beneath those clouds underneath the storm, and that is why the clouds, the storm, the spots of Jupiter has lasted for centuries. So that's a fairly radical prediction, isn't it? And we'll see if that comes true. The images will probably come forth in the next few days, and we'll see what the results of those observations are. So in any case, in that video, he describes the electromagnetic process of why there's a north and the south pole on a lot of these planets, most of them. And what I said in my video is that undoubtedly that there is an electromagnetic process happening in planets, and that is why the rotation of planets happens, and that electromagnetic process comes in the form of something of an electromagnetic inside the planet, or what the astronomers call an electrodynamo. And this is a fairly mainstream idea, not so much the idea that the current actually enters and leaves the planet, and that's why the electromagnet is powered. But that's basically the idea of, like, astronomers, that there's an electrodynamo in there, and that's why we have the north and south poles. So what Wal Thornhill is saying, though, is that there is no such thing at the center of our planet, but instead we are experiencing the effects of our atmosphere, and that our atmosphere is charged, and that is why It's charged with electric current or electric charge, and there's electric current in our atmosphere, and that is the reason we have the north and south poles. That is why we have planetary rotation, and that is why we have the magnetic fields. Okay, so this is basically, I'm starting off with this graphic. It's basically a simple 2D animation of the jet streams that is happening across our planet, and this is actually it's actually an up-to-date forecast, because this goes up to the 20th of July. So this is basically what weather forecast thinks that the jets are going to do in the next few days. And as you can see, the northern jet stream goes from west to east, as well as the gigantic one on the southern hemisphere also travels from west to east. So this is a fairly consistent thing. This has been going on since we could ever remember, we could ever measure this sort of thing. This is a really consistent thing that is a characteristic of our weather patterns on the planet. Now, we can actually get a better representation of this. This is basically a simulation of the jet streams that NASA has done in about 2011, so it's fairly current. I'm sure there's better models, but I was googling it just to be fairly lazy here. We'll play this at 1/4 speed, so you get time to kind of like visualize what's going on here. And as you can see, even though the shape is kind of irregular here, the jet streams are basically fairly consistent here, and they're going from west to east. So they have a counterclockwise rotation. And not only that, if you think of it, the weather patterns and the jet stream itself have a faster rotational speed than the planet Earth. That is why, once again, the weather patterns go generally from west to east. And it should say to you that we have our cause and effect reversed here. Like if you think that the weather patterns were caused by rotation instead of electromagnetic energy being deposited into the planet by these currents, then the weather patterns would be actually reversed, where they would probably be going from east to west instead because of the rotation of our planets. But as you can see, the rotational speed of the weather patterns is actually greater than the rotational speed of our planet. So you have to ask a cause and effect thing here. Like, is the rotation of the weather the cause of some sort of rotational force on the planet, or is the planet being rotated by our atmosphere? And I think it's fairly obvious that that it would be the other way around, that the atmosphere in some way is responsible for the rotation of our planet. So let's play that again, because okay, and we'll get back to this, but we're going to go and do a basic lesson in torque here, right? Okay, this is my physics 101 class right here. It's a very simple concept that a lot of people will just instantly latch onto here, but basically this is a lesson in torque. So this is the explanation of it. The guy in the center here, right? He's got his a hand in the center of the lever, and he's trying to unscrew that wrench, right? And as you can see, he has to apply twice the amount of force as this guy to basically unscrew the bolt from this screw. And the reason is it's an application of torque. The application of torque basically is the force applied to the wrench or the rod or the lever times the length at which he's pushing at, right? So as you can imagine, it's a fairly intuitive process without even doing the math, that the guy pushing at the center of this wrench will have to apply more force to that wrench to unscrew the bolt than this guy right here who has his hand at the end of that wrench, the end of the lever. That's because he's got twice as much the lever, the torque, and therefore he's generating twice the amount of torque, right? Okay, So if there was an electromagnetic at the core of our planet, and it was being fed, even if it was being fed that amount of current to basically try and turn the planet, it would take a hell of a lot more force to turn the planet than if you applied some sort of force out here. That's a basic application, of course. And once again, if you had a very small amount of core here, like even right here, the force needed to turn the planet would be massively much greater than if you had to apply it right here. It would be even less force that you would be required to turn the planet if the jet stream were right here at the equator, because that would be where you had your greatest distance from the center of the planet here. I would argue that the way this jet stream is, that the difference isn't that much, and you can see some bits of that jet stream are kind of at the equator, and at the bottom, as you can see, that the force being generated right here must be a lot more. Like, this is the major current here. The major jet stream is much greater here, and so obviously there's a lot more going on down here at the southern hemisphere than our northern hemisphere jet stream right here. Yeah, so that says to me that our weather patterns are definitely being driven by the electric force, like current traveling from the sun to the jet streams around our planet. We've already seen that the electric force is responsible for the aurora borealis, the northern lights, because there is current, and we saw the simulation of the Birkeland currents in that vacuum chamber, where electricity, even though there was a near vacuum, was flowing between the electric source on the sun ball and the smaller ball, which represented Earth. So there was electricity flowing between the sun and the Earth, and it showed up here in the northern lights. But then there's also more currents being transmitted from the sun to the Earth through these Birkeland currents, and it's traveling all around the Earth in this way. Okay, and we can actually back this up further by looking at Jupiter here, and we've got Jupiter right here. And in this view of Jupiter, I believe this is Voyager 1, right? And this is a viewpoint where they keep the spots in the center, so you can kind of see the weather patterns going around it. And as you kind of see right here, you can see this jet stream right here cutting straight across it's a little bit north of the equator right here, but it's cutting straight across this planet at a quite amazing speed here too. And there's one down here, and this is kind of like a backlash here, but I believe this is kind of in reaction to the Jupiter spot. Once again, Wal Thornhill thinks there's like a moon or a planet down there, and I believe in recent times that spot has gotten a lot smaller, so we might find out what that is. Juno or no Juno, we might find what that spot is pretty soon here. If there's like a massive planet ejected from Jupiter, that would be confirmation of his predictions for sure here. But once again, the jet stream, and undoubtedly the one that has a lot of torque right here, almost all the torque that it can generate, is flowing at a massive speed across the northern hemisphere of that planet here. So yeah, and this is kind of like you can see that the spacecraft is going across, it's kind of like passing the planet now. So it looks like the weather patterns are going left to right, but let's go back and do that. You can see that the spot is disappearing, so the Voyager spacecraft is kind of passing to its right side there. And amazingly enough, this weather pattern right here is keeping up with the rotational speed of Voyager right here. So you can see that Voyager is actually tracing this weather pattern quite well, actually. So yeah. In any case, that's my addition to the last video. In the future video, I'm going to kind of delve into Einstein a little bit, because I know that was brought up and people bring Einstein up to me a lot when kind of arguing with me about this electric universe theory. So we need to bring him up, and we need to tackle the proofs or the evidence that has been presented in support of Einstein. First, we're going to go into the 1919 proof, the one that involved the solar eclipse, because there is a lot of dissenters on that theory, on that proof, and why it was kind of a bad proof to begin with. And to give you a hint, there was a lot of confirmation bias when trying to use that solar eclipse to prove Einstein. Like Eddington had it in his mind that he wanted to prove that theory. So he had confirmation bias. Plus it was World War I, which means there was a lot of political, there's a heavy political charge that was motivating, that was a motivation to kind of prove this theory. Because it was essentially a British scientist reaching out to a German scientist, trying to form that scientific community around and reinvigorate the bonds of the scientific community in the face of a World War I. And while that is admirable in its purpose, it kind of loses its objectivity when it comes to disproving or proving a theory in science. And then the other one is the most recent evidence being presented, which is that gravitational waves observation that was made last year. And this has been read out on the Project Thunderbolts channel, but I will read it out to you, and I will let you guys decide whether the gravitational waves measurement being made as evidence of Einstein is actually valid or not. But like everything else that is on about our lives, you need to treat everything with a heavy dose of skepticism. Like mainstream is the perfect target of skepticism right now, and that includes mainstream science, because every time you turn around, astronomers are really amazed that something happened that they did not expect. So we're going to go with the fact that we're going to go with the notion that mainstream science doesn't really have everything right. In fact, we're going to go with the notion that they don't have a whole lot right, and we'll pick it up from there. So I will see you guys then, and I will see you next time.